So let's talk more about AI and energy. I mean, there's a lot of kind of hysteria going on right now about, oh my God, this industry, this innovation is going to swamp our demand, and we're going to have blackouts, and those sorts of things. Give us your thinking on AI and energy, how you think about that.
Well, AI does take energy.
Yeah.
And so the first thing to realize that before you can use AI, you have to teach an AI. The teaching process consumes a lot of energy. And the reason why it consumes a lot of energy is that the artificial intelligence network, through trial and error, is trying to figure out how to predict something. And it's recognizing patterns and relationship among tons and tons of information. And from all of that data, it finds out what's the relationship and the pattern such that it can learn a knowledge out of it. We call it representations. And so you're trying to discover knowledge out of data.
Right.
And you're just swimming in it, processing it repeatedly, looking for that pattern in relationships. Eventually, you've learned the knowledge that's embedded inside. You've learned all these different relationships that when you're presented with some future patterns, you could understand it. You could even predict it. Okay, and so that's the goal. These data centers could consume today maybe 100 megawatts, and in the future it'll probably be several, 10 times, 20 times more than that. It doesn't have to necessarily be built in one place, and these AI models are going to use synthetic data. For example, two AI models are going to be talking to each other, just like the two of us are,
Right.
and just through conversation, through Q&A, we're going to make each other smarter. And so future AI models are going to rely on other AI models to learn, and you could use AI models to curate the data so that future AI use an AI to teach another AI. And so there's a lot of different ways that AI will learn in the future, but nonetheless, it's going to take energy to do so. The important thing to realize about AI is that it doesn't necessarily care where it learns. It doesn't care where it goes to school. And so there are places in the world where we have excess energy. It's not necessarily connected to the grid. It's hard to transport that energy to population, but we can transport the data center to, we can build a data center near where there's excess energy and use the energy there. The big idea about AI, however, is the goal of AI is to do things more productively, with a lot less energy. And there are a whole bunch of examples of this where we're using AI. One of my favorite examples is using AI to predict weather. By training an AI model, the physics of weather prediction. In the case of weather prediction, it's mostly atmospheric physics. And long-range weather prediction requires you to understand ocean physics, land physics, cloud physics, radiation, reflection, absorption, conduction, convection, right, thermodynamics, right, fluid dynamics. All of those forms of physics comes together to affect the future climate. Well, we can teach an AI how to do that through previous observed data, and we're starting to make great progress there. That AI model can predict weather and predict climate thousands of times, tens of thousands of times more energy efficiently. And so the thing to remember, you teach the AI model a few times, but you use it continuously everywhere around the world. And so the benefits of using AI to predict weather instead of using supercomputers to predict weather as we do now can save a ton of energy.
Yeah.
Using artificial intelligence to solve problems will consume less energy than using calculation to solve problems. Okay, and so that's number one. Number two, we use artificial intelligence now in the smart grid. Our power grid is not smart, but we can make it smart. And so we work with a company called Yili Data and PG&E to create an AI computer, and we put it integrated into the smart grid. The goal is with AI, with intelligence in the grid, you could figure out how to, for example, integrate sustainable energy into it. That sustainable energy could be from solar, it could be the battery sitting in your car. During power surges and outages, It could recognize that there's a weakness in a grid and figure out where the various distributed energy sources are to keep the grid going. Maybe you could predict very subtle signals of when the grid is about to fail and send people out for predictive maintenance. You could also do a better job predicting the surges, the power surges that's about to happen, so you could redirect energy accordingly. So smart grids, I think, is going to make sure help us not over provision in the grid. And so there's lots and lots of examples.
You're a really good teacher. So here we are in Washington, and obviously we're all about federal policy. The federal government has been an important partner on innovating on some of the things that you're talking about. How do you see that history, your work with the U.S. Department of Energy, and then where we ought to go next? I mean, just give your sense of, if you were running the Department of Energy and had a checkbook, how do you see those investments being deployed in the smartest ways?
The thing I recommend most for every employee at NVIDIA, every company CEO that I meet, every leader that I meet, is engage artificial intelligence, try to have a tactical feel for it. We have, through invention of technology, the most advanced computing technology ever created. We have made the computer easier to use than ever, to the point where almost anybody can talk to the computer, prompt it for something, ask it to do something for you, including write software for you, and it will write software for you. And it could make drawings for you, it could create schematics for you, it could make charts and graphs, it could read something for you, translate something for you, summarize something for you, solve problems for you. And so this incredible thing, this computer, is now democratized. For the very first time in history, this incredible system, this incredible technology is available to just a small percentage of the world, is now available to everybody to use. And the first thing to do is to try to understand how you could take advantage of this technology yourself. Some of the important work that we're doing in carbon capture, just trying to figure out in a reservoir how much pressure can we pump into carbon into this reservoir, and how much this reservoir has already been saturated with carbon. And so we could select the best injection wells for carbon capture. And this simulation takes supercomputers, just an enormous amount of calculation. We've taught in AI how to go help us select these sites with nearly 1 million times less energy. And so there's a lot of different ways that we can use artificial intelligence to help. Being inspired by those ideas, I think, would really help DOE. And of course, some of the things that I would recommend is invest in using it yourself. One of the things that I would really love to see the United States do is for the government to become a practitioner of AI. Don't just be a governor of AI, be a practitioner of AI. The DOE, the DOD, every single department, be a practitioner and build an AI supercomputer. The scientists would be more than happy to jump on it and create new AI algorithms, to advance our country.
Yeah, fabulous. There's a lot of obviously implications to the good and a lot of fear around what is the meaning of AI for our American workforce or our workforce globally, obviously, and how you think about that as your own human capital asset as a company and how you develop and grow, but also, the broader implications for the workforce, first in the U.S., but in the world.
The first thing we need to do is demystify this technology for people. And the reason for that is because it's useful to them. It can empower them, but not if they don't understand it. And as it turns out, it's actually relatively easy to understand. Very few people in the world know how to program a computer, but everyone knows how to ask someone else to do something for them. And it's as simple as that. It's as simple as walking up to the computer and tell it, what you want. And for the first time, it might even give you a reasonable answer back. And you don't even need complete sentences. You can be grammatically incorrect. You just, and start. And if it doesn't understand what you mean, it'll actually ask you back what you mean. And just go back and forth until it figures out what you want, and it does it for you. And so the first thing that we've done is we teach a class called Deep Learning Institute, and we go around the world, and we're doing a very large campaign in California, in school, in community colleges, in high schools, and such, and anybody who would like to learn, to teach them about the capabilities of artificial intelligence. We should do that all over the country. We should be teaching everybody, exposing people to this technology. And I think it's easy to use, it's fun to use, inspiring to use. You could ask it to help you draw something, give you a recipe, help you write a business plan.
Yep.
All kinds of things. Yeah.
But how do you think about your own human capital, and what do you look for in your people and your leaders? Is it given all the promise that AI has for the workforce, what are you looking for as you look for and recruit leaders and people to join you in building NVIDIA?
All the same things I looked for in the past. Nothing's going to change. The one thing that's going to change is the amount of software programming that we do. The actual programming that we do will reduce. Or another way of saying it is the way we program computers will change.
Because you're just going to ask the computer to do it.
Exactly. Exactly. We're going to describe very clearly what we want the computer to help us do,
Right.
and the computer will do it for us. And so the way that we would design chips in the future will be describing probably the specifications of the chip, which is telling somebody what you want is oftentimes where the genius is.
Right. Right.
Yeah, where the genius is. Yeah, doing the actual skill, of course, there's great craft and great dedication, and but to be able to explain a future that you would like to create, and have AIs that help you go do that is pretty terrific. And so my prediction is that the first thing companies like ourselves will do is use artificial intelligence to improve our productivity. That's what we've done. We've got AIs all over our companies designing our chips, writing our software, helping us debug things, help us do verification. We're starting to work on using it for marketing and customer support and things like that. And so number one, help us be more productive. When a company becomes more productive, they make more money. When they make more money, they hire more people. And the reason for that is because we have more ideas we'd like to go pursue.
Right, right.
And so I would love for the United States to be more productive, because we'll have more money. And then because we have abundance of ideas, we'll be more prosperous.
Yeah.
And so I think the idea that it's human versus AI is not quite right. It's humans using AI. And with respect to anybody who's concerned about an AI taking their job, you should probably worry about someone who uses AI taking your job.
Yeah.
And so that reminds you to get going and to go learn this new tool.
Yeah.
And to make this new tool, your advantage. And surely as a company, we're going to do that.
Yeah.
And as a country, we should do that.
Wow. Okay, national security. Obviously, a huge, nexus between our nation's security and these issues. Talk about that, how you see the world and the national security implications for this technology.
Countries are starting to awaken to the importance of artificial intelligence to their country. On first principles, it is apparent. And the reason for that is simple. No country in the world would say we should outsource our intelligence to anybody else. Their language, culture, people, their way of thinking is part of their natural resource. And that is codified in data. And so to allow other countries to come in and scrape your data, harvest your data, harvest your natural resource, refine it, and then import it back to you as artificial intelligence is unacceptable.
And happening.
Yeah, that's right. And so countries are starting to realize that they have to take control of their own artificial intelligence production. And this is where the word sovereign AI, if you will, is starting to float around. Countries in the West, countries in the East are quite concerned and quite motivated to secure their AI infrastructure. Just like they secured their telecommunications, their power grids,
their nuclear assets,
their nuclear assets.
Whatever.
They want to really secure their artificial intelligence infrastructure. And so that's really one of the major dynamics that's happening around the world that they realize now, the incredible potential of this technology to accelerate their climbing, if you will, in the world's various social ladders. And so this is a great tool for them to propel their national prosperity. And I think on first principles, people now understand the incredible importance of artificial intelligence for their national security, national prosperity, and national development.
Obviously, we saw some very exciting news last week with Microsoft helping Constellation reopen 3 Mile Island and the power of nuclear to potentially help this AI future. I wonder if you have any thoughts on how nuclear can be an integral part of this. Thank you.
Nuclear is going to be a vital integral part of this. No one energy source will be sufficient for the world.
Yeah.
It's not one particular way versus others, but there are a lot of good ways, but there's no better way than to not waste energy. And there are a couple of ways that we can contribute to doing that. Accelerated computing is one way, and the reason why we've become so successful is because the computational energy necessary to get the work done using the NVIDIA approach is orders of magnitude less than using general purpose computing. And not wasting energy, not wasting money, not wasting time is probably the single best thing we can do. There's a whole bunch of other ways that we could not waste energy. I would really love to see our power grid all be smart. Today, our nation's power grid was built a long time ago because we were one of the earliest countries to become prosperous. And that power grid could benefit from the insertion of artificial intelligence and smart technology into it.
One of the huge challenges with renewable energy today is the interconnection queue. We have thousands of gigawatts of solar, wind, and batteries waiting to connect. What can tech companies like NVIDIA do to speed up the interconnection queue and get that renewable energy generating faster than it is today?
Yeah, the reason why fossil fuel is so effective is because Mother Nature compressed it into a transportable form for us. And we can take it anywhere and refine it from anywhere. And the challenge, of course, with electric energy is the battery costs a lot of money. And solar and sun is only out for about half of the day. And so there are a variety of challenges of sustainable energy in that way. One way that I described earlier is instead of transporting the energy to where we need it, let's transport the data center to where there's energy source. And we can build a data center anywhere. The AI doesn't care where it goes to school. And although we would like the AI to be trained as continuously as possible, taking a nap for a couple of hours while the sun is down, it's okay. Running an AI factory and training an AI doesn't have to be like running a hospital. It doesn't need to have 99.999999% uptime. If it's down a couple of percent, 5% from time to time, it's okay. It's okay. Just stop studying for a few hours, and you'll pick up where you left off.
In the legal sector, the adoption of AI is accelerating, particularly in areas like document analysis, automation, and the regulatory compliance monitoring, which hold significant potential. From your perspective, how do you envision AI technology being utilized in the legal and regulatory industries in the future, and what innovations might we expect to see in these fields? Thank you.
There will be no task done, no knowledge task done in any industry by anyone that will not involve AI in the loop in the near future. Any information knowledge worker. Legal documents and software code reads similarly if well written, and AI contributes to software coding significantly today. We use AI to write our software inside our company. We use AI to debug our software, which is to find the flaws in it. You will use AI to produce legal documents. You will use AI to analyze documents. You will use AI to enhance the legal documents. And so every aspect of information knowledge will involve that. Therefore, all policy will involve AI in the future. And the reason for that is policy is code. It's code for appropriate behavior. And code, if written well, doesn't contradict itself and achieves the mission, the goal of the policy. Almost everything that we do in the future will have AI in the loop and human in the loop. And we'll be collaborating to do everything.